Hey everybody, so we are doing a video on polynomial inequalities right now. In this lesson, I'm starting out graphically because we've actually already discussed how to do an inequality graphically. So I've given you a graph f of x, and we want to determine when the function is greater than 0. I'm going to zoom in on this graph a little bit more. If we had to determine when it's greater than 0, that's when it's above our x-axis. So we can start to see this section here is above 0, and then we have this section here above 0. There are two parts. Notice that it's equal to 0 at -4, and at +1, and at +5. This inequality doesn't care about when it's equal to 0. It only cares about when it's greater than 0. So we would have a solution to that inequality that would say from -4 all the way to +1, but we're not including those boundaries, -4 to +1. And then we have another section. This second part is from +1 to +5. Again, we're not including the boundaries 1 and 5 because those are when it's equal to. So the second part asked, how would your answer change if the question originally said greater than or equal to? So greater than or equal to now is going to include those zeros. This would start at -4, and then it is all the way until 5. I don't need to break this at +1 because it's included this time. It's going all the way to +1 and keep going to +5. So from -4 to 5. Here we have another graph g of x, and we want to determine when this is less than or equal to 0. So pay attention to your inequality sign, less than or equal to here. The first thing I might want to know is when it's equal to 0. So g of x is equal to 0 when x is -3, that's one of the zeros. When x is -2, when x is 0, and when x is 3. If the inequality wants to know when it's less than or equal to, it's less than 0 in this beginning section, but it's equal to at -3. So to describe that section, we would go from -∞ all the way to -3 with a bracket. It has another section when it's less than 0 in between here. It is equal to 0 at -2 and at 0. So that would go from -2 to 0. This also has a third part. Because this asks when it's equal to, I get to include the 3 as well. Now it's not less than there, but it doesn't have to be. It says less than or equal to. So we want to join that together with that 3, and it's just 3. So we use those little squiggly brackets and put that on the end. For question 4, we have a quadratic equation. H of x is x squared minus 11x plus 28. And we want to figure out when is this function greater than 0. To do this graphically, I would need to sketch out what this graph looks like. I know it's a quadratic, so it's going to have a parabola shape. but I need some more information. If we care about when it's greater than 0, I might first need to figure out when is it equal to 0. We can figure out the zeros of the function by putting it in factored form. So the factored form part is really helpful. This would be x minus 7 times x minus 4. So it has zeros at 7 and 4. Graphically, we have a parabola, 1, 2, 3, 4. So a parabola going through 4, 5, 6, 7, and 7. It's opening up since it's a positive x squared term. I could find the vertex, but honestly, it's not asking anything about where that vertex is. It wants to know when it's greater than 0. It would be greater than 0 in these two sections here. So that's happening from negative infinity, our solution. It's going to say from negative infinity all the way up until 4. And we're not including 4 because it doesn't include when it's equal to 0. Union, and then 7 to positive infinity. One way to solve inequalities is to think about them graphically. But we can also think about this algebraically. So sometimes it's hard to create the graph, especially for a more complex function. So we need an algebraic approach. This first one's 2x squared minus x is less than 15. The very first thing we're going to want to do is figure out when this is equal to 0. So I'm going to set this inequality to 0 by moving that 15 over. This would say 2x squared minus x minus 15 is less than 0. I don't want to change this to equal to 0 right now. I really want that less than sign, but I'm going to continue to factor. And we would factor this quadratic equation. Thankfully, we've been working on our factoring skills. So that factors into 2x plus 5 times x minus 3. This will help me find the zeros. The factored form reveals that the zeros are at negative 5/2 and at positive 3. Graphically, those are when it's equal to 0 and it's crossing the x-axis. So we could approach this graphically. We would have negative 5/2 somewhere, a positive 3 somewhere, and it would cross at those 2 points. This is a positive x squared graph, so it would be opening up and it would look something like this. Because it's a quadratic, that's actually pretty easy to do, or at least it's easier than some of the others. When we care about when it's less than 0, that would be this middle section here. Let me move that paper over so you can see. So between negative 5/2 and positive 3 is the actual solution. I'm going to show us a different way to figure that out, but I'm going to go ahead and write that solution down. So parentheses, negative 5/2 to 3, parentheses. We're not including when it's equal to 0, only when it's less than 0. Graphically, that was that approach. Without doing a graph, we can still think about this number line and try to test out where the function is, if it's positive or negative, if it's above 0 or below 0. So what we do is create our number line and do some test intervals. So we're going to test each interval here. And this is called a sign chart analysis. to do a sign chart analysis, we're picking a value in each interval, and really we only care about the signs of the function at that value. So pick a number to the left of -5/2. That's -2.5. So you could pick something like -3 or -4 or even -1,000,000. So I'm going to pick -3 and plug that value in. I can plug it into this factored form here or that standard form and see is it less than 0 there. I like to use the factored form because it's somewhat quicker, but I have 2 times -3 plus 5 times -3 minus 3. The goal isn't really to find out what it is exactly equal to, but more about the signs of this. So if I had 2 times -3, that's -6. -6 plus 5 is -1, but that's a negative number. -3 minus 3 is -6, but really in general, it's a negative number. So if you have a negative times a negative, you end up with a positive. So this section to the left is positive. It's above 0. Graphically, we already knew that. Then we could test out a number in between -5/2 and 3. A number in between there that's easy to use is 0. So I'm going to try out x equals 0. That would be 2 times 0 plus 5 and 0 minus 3. That gives me a positive number times a negative number, which is negative. That's why the middle section was below the x-axis in the negative section. And then we pick a number to the right of 3, something like 4, 5, 6, or 1,000,000. I plug that in. 2 times 4 plus 5 times 4 minus 3. That is a positive number times a positive number, which is positive. So that last section was positive. We only care about when this inequality is less than 0. That happened in the middle between -5/2 and 3. So that solution, we write in interval notation, but we do get -5/2 to 3. We can do this with any quadratic or polynomial equation, and we're going to do that with other types of functions as well, so we'll eventually do rational inequalities. With this one, we have 3x squared plus 7x minus 20 is greater than or equal to 0. I would first need to factor this. (3x squared) is 3x times x, and we find our factors of 20. Let's see, so we can do 4 and 5 here. That would give me 12x minus 5x is 7x. So 3x minus 5 times x plus 4. If we multiply it back out, we do get the 3x squared plus 7x minus 20. From those, we can find the zeros. Our zeros would be at 5/3 and -4. If you want to do the graphical approach, you can. It's just easier with quadratics than it is with any other type of function. So I encourage you to start trying out the sign chart test. Even though it might be easier to do graphically with quadratics, the sign chart test is going to work for every inequality like this. -4 happens before we get to the positive 5/3. And this does include when it's equal to 0. So we are including the zeros here. We would need to test out the signs for each interval. So I can pick something like -5. -5 is to the left of -4. I don't always show every single part of this. I just start plugging these things in. So negative 5 times 3 is negative 15. Negative 15 minus 5 is negative 20. So I have a negative number. Negative 5 plus 4 is negative 1. So I have a negative number. We have a negative times a negative, which is positive. So I know this section here is positive. Then we would test out a number in the middle. 0 is an easy number, but you can pick any number in between negative 4 and positive 5/3. If I plug in 0, I have 3 times 0 is 0. 0 minus 5 is negative 5, so that's a negative number. And 0 plus 4 is a positive number. We get a negative times a positive, which is negative. And we pick something to the right of 5/3. Now, if you're not sure what those values are, you just need to go into your calculator and figure out what is 5/3. 1.666 repeating. And you pick something to the right of it. If you want to just be sure that you picked something to the right, go a lot bigger. 10 is definitely to the right of it. If I plug in 10, I have 3 times 10 is 30. 30 minus 5 is 25, so that's a positive number. And 10 plus 4 is a positive number. We have a positive times a positive, which is positive. And we care about when this is greater than or equal to 0. That would be this section here to the right or equal to, this section here to the left or equal to. We write out our solution in interval notation. That solution would be negative infinity to negative 4 with a bracket, union, and then 5/3 with a bracket to infinity. So now I finally give you one that is a polynomial. Number 3 says, if the polynomial is already factored, then we can find the zeros pretty easily and do our sign chart analysis. We would not want to multiply this problem out to get into standard form because the goal is to get it in factored form anyway, and we don't want to have to work back all the way to the factored form. We already know the zeros, or the factors, so that we can find the zeros. Here, in the factored form, we find zeros of positive 4, negative 3, and positive 1. We put those on our number line. One thing that I tend to do is put the inequality part off to the right to just kind of serve as a reminder of what am I looking for. I want to know when it's greater than 0. I do know that it's equal to 0 at negative 3, positive 1, and positive 4. We are not including those zeros. So I'm going to use open circles there because we only care about when it's greater than 0. The reason the sign chart test is somewhat easier is because for these, to do a graphical approach, we have to think about multiplicities, we have to think about end behavior, and how that graph shape is going to look. So there's a little bit more to it than just a parabola shape. I would pick a number to test out in each interval. All right, so something to the left of negative 3 could be something like negative 4. If I plug that in, negative 4 minus 4 is still negative. Negative 4 plus 3 is still negative. And negative 4 minus 1 is still negative. A negative times a negative times a negative is negative. So this section to the left of negative 3 is negative. All right, we pick a number in between negative 3 and positive 1. Easy number there is 0. So if I plug in 0, I have 0 minus 4 is negative. 0 plus 3 is positive. And 0 minus 1 is negative. Negative times a positive times a negative will be positive. All right, just to save space, I'm going down here, but we have to pick a number in between 1 and 4, something like 2. Sometimes you might have to plug in decimals. For this, 2 minus 4 is negative. 2 plus 3 is positive. 2 minus 1 is positive. We have a negative times a positive, which is negative. So that section there is negative. And we do one last section over here to the right. I'm going to plug in 5 because that's to the right of 4. 5 minus 4 is positive. 5 plus 3 is positive. And 5 minus 1 is positive. We have a positive times a positive times a positive. So that section is positive. We care about when this is greater than 0. That does not include the zeros. That's why they're open circles there. But we can see when it's positive, it's greater than 0. And then we write that in in interval notation. Our solution for this one would say parentheses -3 to 1 union 4 to infinity. Right. So we've got 2 more here. Number 4 is x minus 3 squared times x plus 5. Notice this is already in factored form. We do not want to go all the way out into standard form. It just makes our life more difficult because we already care about the zeros of this function. The zeros here would be at x equals 3. There is a multiplicity of 2, but that's not going to matter. We just care about the zeros. And then at -5. So I put those zeros on the number line. I have -5 and +3. This inequality does not include those zeros. And then you do your sign chart analysis. If you want to pause the video and go ahead and do your sign chart analysis and test out your answer, that's fine. If you just want to keep going with me, we can do that too. So I'm going to test out -6 and plug that in. With these, you do want to be careful because you're doing -6 minus 3 squared. That is a negative number, but you're squaring it, so it's going to come out positive. So think of that as a negative number squared times a negative. That's a positive number times a negative, which is negative. So this section here to the left is negative. Then we pick a number in between, like 0. That's an easy one. 0 minus 3 squared times 0 plus 5 is a positive number because it's squared, and then times a positive number, which is positive. We pick a number to the right, like 4. And I plug that in. 4 minus 3 squared times 4 plus 5 is a positive times a positive, which is positive. If we care about when it's greater than 0, those are the positive sections here. It does not include when it's equal to 0. And we translate that into interval notation. Our solution would say parentheses -5 up to 3 with a parentheses, union 3 to infinity. Now, if this had said equal to, greater than or equal to, those would be filled in, and there would be no reason to break it at 3. You would just go from -5 to positive infinity. All right, your last one, number 5, is 6x cubed minus 36x is less than -5x squared plus 30. This one's a little bit different because it's not already in factored form. So we treat it like we did with the quadratics. We get it equal to 0 so that we can put it in factored form. I'm going to take this 6x cubed and add 5x squared over, so plus 5x squared, minus 36x, and then subtract your 30 over, and now it's less than 0. Everything is technically in standard form now, and I can factor, hopefully by grouping, because there are 4 terms. So I'm going to group these together. We get an x squared that factors out. 6x plus 5 is left over. So x squared times 6x plus 5. And then we factor out a GCF here of minus 6. And that's 6x plus 5 as well. It's still less than 0, but we want to put this in factored form. So our common factor, 6x plus 5, would factor out times x squared minus 6. This doesn't factor more, and that's okay. It doesn't have to, but I can find the zeros. The zeros would be when the factor is equal to 0. So one of them is at negative 5/6. This x squared minus 6 equals 0. When we solve that, we get 2 zeros here. One's at positive square root of 6 and one's at negative square root of 6. We would put those values on our number line, even though they're ugly, and that's okay. We still want to know when this is less than 0. These values that we found are when it's equal to 0. But I may not know where the square root of 6 is. So I have to go into my calculator and figure out what is the square root of 6. Your calculator will automatically give you this square root of 6 again, unless you press this or approximate button above the enter. When you press that, you get 2.449. So this is approximately plus or minus 2.449. And 5/6, if you need the decimal there, it's negative 0.08. So on a number line, your negative square root of 6 comes first. Then you have your negative 5/6, and then you have the square root of 6. These are not included. If you want to write your decimal values, you can say it's approximately negative 2.449, approximately negative 0.833, and approximately positive 2.449. Those might help you figure out what your test values will be, but you test each interval. And then you see, is it positive, negative, what's going on there? All right, so in this case, after I do this, I should end up with these intervals, a negative, a positive, a negative, and then a positive. We care about when it's less than 0, which is this area to the left here of negative square root of 6, and this area in between negative 5/6 and the square root of 6. So our solution would be from negative infinity to negative square root of 6, union negative 5/6 to square root of 6. All right, and there's our polynomial inequalities.